All right, hello. So since we have reviewed limits, and hopefully you feel pretty good about limits, I'd like to start the next two targets, which they're both derivatives. All right, so now we want to talk about, do we remember all the derivative rules? All right, so the first one's the power rule. Hopefully you remember the power rule. So if you have a problem like y equals 3x to the fifth, the derivative of that is multiply the exponent times the coefficient, 15, and then drop a degree. It's power rule. So that one should be one that we remember readily. All right. The next one we learned was product rule. All right. So if we have something that is like 3x plus 1 multiplied by x squared minus 7. Our derivative is a product. This is a product, so our derivative would have to involve product rule. So if you remember, your product rule is the first function times the derivative of the second function plus second function times the derivative of the first function. So it's first times the derivative of the second plus the second times the derivative of the first. All right, so that was product rule. And then we also learned quotient rule. All right, so our quotient rule. So let's say we had a problem like, I don't know, I'll just use the ones I had up there. 3x plus 1 divided by x squared minus 7. So now this is a quotient, all right, because it's a fraction. So the quotient rule was the HODI high, all right. So y prime in this case is the HO d high minus high d ho all over ho. So x squared minus 7 quantity squared. So ho d high minus high d ho over ho. All right. So that's power rule, product rule, and quotient rule. Hopefully you remember those. All right. And then the next one we learned was the chain rule. Well, chain rule is just if you have all these other rules with a little bit more complicated function. So you would have an outside function and an inside function. So for instance, if I had 3 times, I'll look up here with the power rule. Let's say I've got 3 times x squared plus 1 raised to the 5th power. So in this case, instead of just being 3x to the 5th, I've got 3 and then this other new function raised to the 5th power. So I have a function embedded inside of 3x to the 5th. So this is where it involves chain. So remember, chain rule, you do the outside function first, which is your power rule. So you'd multiply the power times the front. Then you would copy all this over, x squared plus 1, and you drop a degree. And whatever you copied over, you have to chain on its derivative. So then I would chain on the derivative of 2x. All right, so that was your chain rule. So that's when you have any of these other rules and you have a function inside a function. You've got to apply the chain rule each time. All right, so that's chain rule. All right, the next thing we need to talk about a review would be trig functions. All right, so any trig functions, those are the ones that you're supposed to have all memorized, like the derivative of sine is cosine, derivative of cosine is negative sine. And so you just need to go back and review all those derivatives, all right? You can do that on your own. I don't have to do that. But you can also have to involve chain rule in these. So for instance, let's say I had a chain rule involved in a trig function. So let's say I had y equals, let's just practice one, tangent squared, and inside behind the tangent, let's say we have x squared plus 1. All right? So I want to find the derivative of this function. All right? So let's say, oh, I've made this a big chain rule. All right, a lot more complicated, I think, than I wanted to, but we're going to do it anyway. All right, so the first thing you need to do to this is you need to rewrite it, remember, with the powers on the outside. All right, so now this is going to be a good one. All right, so let me move over and give myself plenty of space. Okay, so because I did tangent squared of a quantity x squared plus 1, I need to rewrite this because you remember in pre-cal, we always put the little 2 here between the tangent and the argument, the actual angle. And that's a shortcut notation. So you move it on the outside to remind yourself it's an exponent, so we got to use power rule. All right, so this is going to be a function embedded in a function embedded in another function. So I've really embedded 2 things here. So we're going to start with power rule. So I'm going to do the power rule first, so that'd be 2. Then I'm going to copy everything over, so that'd be the tangent of x squared plus 1. All right, I copied all that over, and then I drop a degree. So then if that had been a 3, I would have put a 3 to the front, and I would put this in parentheses and drop to a 2. But I put a 2, so dropping a degree just means I have all this to the first power. So I could be done there. Now, because I copied this over, the tangent x squared plus 1, I have to do the chain rule of the tangent x squared plus 1. So what's the derivative of tangent? Because he's the outside function. Well, the derivative of tangent is secant squared. And then I keep the argument x squared plus 1. I keep this the same. So now, since I kept that the same, I have to chain on again the derivative of the inside, which is 2x. So there's my answer. So it's going to be 2, all of this to the first power, which is just tangent x squared plus 1. Then I have to chain on the derivative of tangent of x squared plus 1, which is secant squared of x squared plus 1. And then I have to chain on the derivative of the angle. And once you've done that, you're finished with trig problems when you chain on the angle. And the derivative of x squared plus 1 is 2x. So that problem's done. So you can have chains inside of your trig functions. So just remember that. All right, the next thing we learned about that we want to talk about with just taking derivatives is implicit differentiation. Implicit differentiation. Now, all implicit differentiation is we don't have the equation set in y equals form. So implicit differentiation, you might have something like 3xy minus x squared equals 10. And you're asked to find this derivative. Now, this one that I wrote, I could actually solve for y because I only gave you 1. This problem, you really could solve for y and actually take the derivative. It would probably end up being a hody-high. But let's take this derivative implicitly, meaning we're just going to start here on the left-hand side and take the derivative left to right. All right, so this first one that I gave us here is actually a product. So I have to do product rule. So the 3x is going to be my first function. The y is going to be my second function. So I got to use product on this part right here because 2 different variables, 2 different functions. All right, so product rule. So it's going to be the first function, 3x, times the derivative of the second function. Now the derivative of y, remember we're taking the derivative in terms of x. So the derivative of y is 1, and then you have to chain on the dy dx, meaning we're taking the derivative of y in terms of x's. So it's first function times the derivative of the second, which is dy dx for y. Then it's plus second function times the derivative of the first one, which would be 3. So there's the derivative of that first part. Okay? All right. Minus the derivative of x squared is 2x equals the derivative of 10 is 0. So I had to do product rule for this one. I'm getting too close to my tablet. Okay. Product rule for that part. First d second plus second d first, and minus the derivative of x squared is 2x because we're taking the derivative in terms of x's, and derivative of 10, derivative of a constant is always 0. So now, in order to find your actual derivative, you have to solve for the dy dx. All right, so that means I need to move this stuff to the other side. So I'm going to keep the 3x and the dy dx on this side. Move these 2 terms over to the other side. So that's going to add a 2x. And that will minus a 3y when I move that, when I minus that stuff over to the other side. Okay? Now to solve for the dy dx, you just have to divide by 3x. So we divide by 3x on both sides. So our derivative, dy dx, is going to be 2x minus 3y divided by 3x, and that's our answer. So remember, that's implicit differentiation when you're solving something in its normal equation form. All right, when we're not solved for y. All right, let's see. That was implicit differentiation. All right, another thing we learned was logarithmic differentiation. All right, now logarithmic differentiation is when you have something like y equals x raised to the x squared. So logarithmic differentiation is a nice tool or way of finding the derivative if you have variables raised to variables. Okay, so we need to get this x squared out of the exponent. So in order to do that, you need to use logarithms. So we typically use natural log because it's the easiest one to work with. Natural log has an easy derivative. So I'm going to take the natural log on both sides. That's all I'm doing. So I just put an ln in front of both of those. All right. Now I'm going to use the fact that I know when I have logarithms, one of the rules of logarithms is you can move your exponent to the front. All right. And that's the whole reason why you're doing it, is so you can get that variable out of the exponent. So I'm going to move x squared to the front. All right. So that's what I have right now. So now this is very easy to take the derivative of. All right, so do we remember how to take the derivative of ln? Because that's actually, I think, in the second half of my video, so I guess I'll do it right now. All right, if you remember taking the derivative of the natural log of some function, all right, so anytime you take the derivative of ln of some function, it's always the derivative of the function divided by the function. All right. So anytime you take the derivative of ln of some expression, it's the derivative of the expression divided by the expression. So the derivative of ln, the ln goes away. All right. So over here, I want the derivative of the natural log of y. All right. So I need the derivative of y, which is 1, divided by the function itself. So that'll be a y. All right. On this side, we're going to do product rule. Okay, so the derivative of this, derivative of y was 1, and then the y on the bottom. All right, derivative over a function. All right, this is product rule. Okay, oh, and I forgot my dy dx. I knew I was doing something. So the derivative of y is 1 dy dx, and then I'm dividing by the y. All right, there we go. All right, then over here, I want to do product rule. So I've got first times the derivative of this. So remember, we're taking the derivative in x's, which is why I put the dy dx over on this side. All right, so I've got the derivative of x is 1 divided by x. All right, then we're doing product rule plus second function times the derivative of the first one. So I did first times the derivative of the second plus the second times the derivative of the first. All right, and on this side, the derivative of ln of y is 1 over y, but I've got to have that dy dx because of the chain rule. So now to solve for your derivative, which is the dy dx, remember each time we did logarithmic differentiation, you always multiplied y over to the other side. All right, and we can also simplify this a little bit right here. X squared over x would just be x, and then I would move the 2x in front just so I wouldn't get confused. And all of this gets multiplied by y. So if you really wanted to distribute that across, you could have x times y plus 2xy ln of x. And there's your derivative. So logarithmic differentiation, the purpose of it, we don't do it real often, but the purpose of logarithmic differentiation is because you've got this variable in the exponent. All right, so you want to get that out of the exponent so that you can take the derivative a whole lot easier. All right, and anytime, don't forget, which I did a few minutes ago, anytime you take the derivative of a y, you chain on the dy dx. All right, so that was logarithmic differentiation. All right, and the last thing I want to review with you, this is very quick, just going through all the rules of everything we learned. The last one I want to review with you real quick is inverses. How do you find the derivative of the inverse? All right, so let's say I had a function, and my function, we'll just make it not too hard here. We'll do x squared minus 1. All right, So I've got x squared minus 1. Now what I want to find the derivative of the inverse. All right, I want to find this. And I want to find it at x equals, let's just say 8. All right, so I want to find the derivative of the inverse function of this function I was given. And I want the value of its derivative when x is 8. Okay, so if you remember the relationship between inverse functions, their derivatives are reciprocals of each other. So if I can find the value of the derivative for this function, then all I got to do is turn my answer upside down. Now, the catch is this. The 8 is the x coordinate over here for the inverse. And remember, with inverses, the domain and range switch. So that means this 8 is the y coordinate for my function. So the first thing I'm going to do is I'm going to set x squared minus 1 equal to 8. So that'll be x squared equals 9. So that's going to give me x equals 3. Okay? So now, that means for this function, oh, I didn't mean to do that. All right, that means for this function, my point is 3, 8. And over here, the point is, I'll put it down here, 8, 3. Because remember, domain and range switches when you have inverse functions. All right, domain and range switch. They reverse. Okay, so now I know my x coordinate for this function is 3. So I can do f prime of x over here. The derivative of this is 2x. And the value at 3 for that derivative is 6. So that means for my inverse's derivative at 8, because his x coordinate is 8, his derivative is going to be the reciprocal of this one. So the answer is going to be 1/6. So if you remember inverse functions, all we learned about inverse functions is that their derivatives at their mirror points, where here we have 3, 8, and 8, 3, the mirror points, their derivatives are reciprocals of each other. And that's just the main thing, the big thing you got to remember about inverse functions. All right, so that was a quick little video going through all of the derivatives that we learned real quick last year. Now we're going to do some practice.